Hello everyone, welcome to Young Innovators. Hope all enjoyed our previous video on 555 IC and tried the circuits on your own. Now we will look into sensors and its types and understand one type of sensor in detail. We can sense what happens around us, like we feel cold, we feel hot, we can sense the sweetness or sourness in the food, etc. Human body has many sensors which help us touch, feel, listen and see things around us. In the same way, we have few electronic components or products that produce the output based on what it senses in its surroundings. Such components have sensors assembled within them, which enables them to sense and produce output. Sensors are an integral part of modern living. If you are watching this video on a computer, you are most likely using an external mouse, which contains an optical sensor. If you are using mobiles to watch this video, you are watching it using a touchscreen, which consists of a touch sensor. We can see sensors all around us most of the time. Now, the question that arises is, what are these sensors? How do they look or how do they work? In simple words, a sensor is a device that measures input from its surrounding environment and converts it into data that can be translated by either a human or a machine. Normally, people use sensors to measure temperature, detect smoke, detect motion, etc. We have both digital and analog sensors in use based on the application. Let's see what analog sensors are. Analog sensors convert physical data into a continuous signal, that is, which will give output at all time continuously. Analog sensors are much more precise than digital sensors, as they give precise value of reading and are continuously monitoring the signals that they receive. Accelerometer, LDR, pressure sensor can be taken as some examples for analog sensor. Now looking at a digital sensor, digital sensors are the one in which data conversion and data transmission takes place digitally and has only two states, that is, yes or no. When the data is sensed, the output is yes, and when there is no data, the output is no. If it's sensing, the output will be seen, and when it is not sensing, there will be no output seen. IR sensors, reed switch, touch sensor are a few examples for digital sensor. We all have been to malls, and some of us would have experienced that glass doors open when we walk towards it or stand in front of it. Also, the escalator moves when we step on it. Such devices are called as automated machines and have sensors integrated with them. The type of sensor which is present in these doors or escalators are motion sensors. We will look into a type of motion sensor now, a PIR sensor. A PIR sensor is a passive infrared sensor that often detects motion. It has pyroelectric sensor, condition variation modules, all placed on a circuit board covered with a plastic dome-shaped lens. The motion detector detects motion based on the IR radiation emitted by the objects that come in its range. A PIR sensor can detect the motion of object in and around it up to 10 meters range. A PIR sensor module is as shown. It has 3 pins: VCC, ground and output. Let's move to Tinkercad workspace and build the circuit now. Here is the circuit diagram. We shall build the circuit according to the same. In Tinkercad, the PIR pins are as mentioned: signal, power and ground. Those are the same as output, VCC and ground. The components needed for the circuit are a breadboard, a PIR sensor, an LED, a resistor and a battery. We will take 470 ohm resistor for the circuit. Let's connect all the components now. Let's place the component on breadboard as needed. First, let us give the connection of the battery to the power leads of the breadboard. Now, let us connect the VCC of the sensor to the positive lead on the breadboard. Next, we will connect the ground pin to the negative lead on the breadboard. Lastly, let's connect the output pin of the sensor to the LED with a resistor in between. The cathode terminal of the LED will be given either to the negative lead on the breadboard or to the ground terminal of the sensor. We will connect it to the negative lead of the breadboard. This completes the circuit. Let's start simulation. The LED glows if I move the cursor within the range of the sensor, and if I keep the cursor stagnant without touching it or without moving it, then the LED will turn off. With this circuit, we understand the working of a PIR sensor and how to make the connections using a PIR sensor. Hope you all got to know the same. PIR sensors are used in many applications like surveillance systems, door alarms, automatic doors, fire or smoke detectors, etc. Hope to see you all in the next video with a new interesting topic. Thank you for watching.